Now we're going to talk about one of my favorite topics, polynomials. And I've called this polynomial expressions to cover all the possibilities. But polynomials are wonderful. As you'll find out later, they're called functions. But we're just going to look at them as expressions right now. The first thing we're going to answer is, what is a polynomial? Because that is the essential idea at the beginning. And then we'll see what we can do with these things. So, what is a polynomial and why the funny name? Well, poly means many. And it will include, of course, includes one. So we cover all the cases there. And the nomial part, there actually is a word that's based on nomial, but we can think about this as just terms. Okay? There'll be terms of a certain kind, as I'll explain. And poly, you've seen, it means many. You've seen it in other words like polygon or polyglot, a person who speaks many languages. But what we will do here is, because we don't want to do many first, we'll do one first. We start with a one-term polynomial. Okay, so we start very simply, and we'll work our way up to the general case. So here's the definition I'm going to write down. And the next page will have even more, but I can start it here. Definition A, well, what will I call it? If that was poly, we'll use another root from a dead language. Polynomial. We'll use monomial. A monomial has the form, and I'll go to the form on the next page. Why do I call it monomial? Well, you see the word mono there, which stands for one. You've seen the word mono in other words like monorail or monotone or monopoly or monogamy. All of those words have mono in them, indicating one for some reason. So this is a monomial, and that's the reason for that. Now it's going to have the form that I'm going to write down here, but I'm going to entitle this page Anatomy of a Monomial in one variable. So we'll explain exactly what a monomial looks like in one variable. It has what form? It has this form. A sub n times box to the n. So I'm going to have to explain all of this, but that's the form. It's a single thing. Notice that it is one term. Terms, remember, are things that are added, and this is one thing that will be added to other things. All right, let's first start on the left here with this a sub n. This is a real number. In other words, it's a constant. It's given a name. It's called a coefficient. That is another piece of terminology you have to learn about polynomials. All the constants that are multiplied are called coefficients. And finally, the subscript, n, is a label. That's all it is. It says, I am the constant that goes with whatever the box power is. So this is the number that is multiplied by something to the n. All right. What goes in the box, you may ask? What goes in the box is a variable. And the variable, of course, can be anything. It can be x, it can be y, it can be u, it can be v, etc. Usual variable letters. So what goes in there is a variable. So we have a constant times a variable to a power. Well, what kind of powers are allowed? This is a power, n. It is allowed to be 0, 1, 2, 3, etc. So the powers in a polynomial do not include negative numbers. Not negative. It's also not rational. There are no fractions there. And it is called the degree of the polynomial. The degree of, of the monomial. We're just looking at a monomial right now. Of course, a monomial is a polynomial. It's just a polynomial with only one term. So I've got a lot on the page here. This is the anatomy lesson. A sub n times a variable to the nth power. This is a constant called the coefficient. This is a variable. And this is the power that's only allowed to be 0, 1, 2, 3, etc. Never negative, never rational. And this number will be referred to as the degree of the monomial. So with that in mind, let's go ahead and write out a few of these so you know what I'm talking about. Here's an example. 2x cubed. There is a nice simple monomial. Here's another one. Square root of 2 times x to the 5th. See, the constant doesn't have to be a nice number. It can be an irrational number. Here's another one that you may not expect. 7. I claim that that's a monomial. Well, you say, there's the constant. Where's the power? Well, remember, the power could be 0. So you can think of this as 7 times x to the 0. In other words, all constants are monomials. You could have 4.36 times y, just to change the variable. You could have 8/9 times u to the 101 power, etc. Those are what monomials are. Constants times variables to powers. Okay. Now that we have these new objects, we ask ourselves, what can we do with them? One of the things we can do is add them, and we'll get a notation for that, a terminology for that. 2 monomials with the same degree, got to have that, with the same degree. Remember what degree is? It is the power of the variable, and same variable. So they both are x's, say, are called, if you have 2 monomials with the same degree and the same variable, they are called like terms. They are terms that are alike in all the essential parts. They have the same variable to the same power. The constant out front may not be the same, but this is the definition of like terms. So ax to the n and bx to the n in general are going to be like terms. The a and b may not be the same, but the variable is the same and the power is the same. Well, let's see what you can do with those. Of course, you can combine them. We can combine like terms. We have this new phrase now, combine like terms, as follows. Let me give you an example. Suppose you're faced with 2x squared plus 5x cubed minus x squared plus x plus 1 plus 10x. There, how do you like that? Now there's a bunch of monomials added together. Again, our goal in mathematics is not to complicate things, but always to make them simpler. Because if they're simpler, you can understand what's going on and perhaps solve whatever problem you're looking at. All I want to do is simplify this. So what I'm going to do is combine the terms that are alike, in that they have the same variable. Well, all of these share the same variable. That's not a problem. And they have the same degree, the same power. So let's see what we've got, and let's be systematic about it. Let's find out the highest power. That's this one, 3. Is there anything else with the power of 3? No. So 5x cubed here will just stay. Then I look through for squares. There's a square. There's another square. I have 2 things with squares. 2x squared minus x squared leaves me with plus 1x squared. Then I move down from 3 to 2 to 1. There's a 1 power. There's another one of 1 power, an x and a 10x. So I can write down 11x. And finally I go down to the 0 power. That is the constants. I see I have 1 constant here, 1. So I have plus 1. Now in this I have combined all of the like terms. Unless I know more information, this is as simple as I can make this expression. All right. This is now reduced to different monomials, because if any of them were like, I could have added them. And that's what we wanted to do at that point. Okay, those are monomials. Monomials are polynomials of one term. Now, some polynomials have names. Now, note, a few polynomials actually have special names. Now, why is that? Well, because of history, or because they're ones that turn up frequently. For example, a constant polynomial. What is that? That is, another way of saying that is, it is a polynomial of degree 0. What's next in line after a constant? Well, a n x to the n. Of course, you know that that's a monomial. And what is that? That's a polynomial with one term. All right. Now we're going to go ahead and look at some polynomials and the names for ones with a few more terms. What if you had something that looked like this? You had some an x to the n and then added to it and b m, say x to the m. Now we're staying with a single variable because that's what we want to look at, although there could be different variables. This is two different things. These are not like because the variable is the same but the powers are different. So these are not like terms that can't be added. So this is referred to as a binomial. Bi, as in bicycle. Two things. A binomial. And what is this? This is a sum of two monomials. And since there are many, many cases where binomials turn up, that's why there is a special name for them. Now we're going to look at a lot of simple ones on the next page, so don't get put off by this notation. And let me mention one more. I'll even write the name before I write it. It's going to be called a trinomial. And you can guess what that is. It's going to be a sum of three monomials. Now you can see that this can go on forever. In fact, most of what we will deal with will involve binomials, monomials, and constants. What's a trinomial look like? Well, it's going to be just like a binomial, except there's one more term, say c sub k x to the k. And as I said, don't let the notation throw you. Let me get away from it right now and show you examples of these. Binomials have two monomials. Trinomials have three. That's all there is to it. So, for example, x squared minus 2 is a binomial. 2x plus 3 is a binomial. X squared plus y squared is a binomial. The variables don't have to be the same. So these are binomials. Likewise, just for the record, x squared plus 2x plus 1 is a trinomial. Y squared minus x squared plus 2 is another trinomial. X to the 20th minus x plus 5 is a trinomial. So these are all trinomials. They have three. And for the rest of them, as I say, we just call them generically polynomials. We don't have any special names. Well, on that note, let's define finally a polynomial in one variable. Definition. A polynomial which covers everything we've seen before, even though we gave some of them special names. Polynomial is a generic term. A polynomial in one variable, and today I'll use the variable x, has the standard form, and standard forms, as I've said before, are very important in mathematics, and you'll see that even later. Standard form, and what is the standard form? The standard form is that the higher powers go down to lower powers. You have it organized so that the highest powers of the variable are at the left, the lowest, meaning the constants, if there are any, at the right. And what will be the form? It will be this. A sub n, x to the n. Got to write it out in general now. A sub n minus 1, x to the n minus 1, plus down to a sub 1x plus a sub 0. And you notice when I say these subscripts, I say sub. So a sub n, x to the n. To the means a superscript, sub means a subscript. And these go down. We always assume that an, the original one starting at the beginning, this is called the leading coefficient. Remember, all those constants are called coefficients. This is called the leading coefficient because, well, it leads. We always assume that's not 0 because if it were 0, we could have started the polynomial here with an minus 1. So we always assume that the first one that we start with is non-zero. That only makes good sense. An all the way down to a naught are constants. And again, for us, remember, that means real number constants. And of course, n is called the degree of the polynomial. It is the highest power of x that occurs in this one variable polynomial. So that's what a polynomial is. It really is a wonderful instrument as we work further in the course. But let me give you some examples. Example. These are some polynomials. Here's one. X to the 20th minus x to the 13th plus x. Here's another one. 2x to the 50th. I'm trying to take high powers here to give you a sense of what's going on. Plus x to the 49th plus 5x squared minus 37. How about that? Here's another polynomial. 8. Remember, constants qualify because that's really 8 times x to the 0. So it's a polynomial. In fact, it's a monomial. And then here's a binomial. 97 x to the 100 power plus 1, and so on. You can create as many as you like. The important thing for us is to realize what's a polynomial, these things are polynomials, and what's not a polynomial. Let me show you some non-polynomials. These are not polynomials, just so we're clear. These are not polynomials. 1 over x is not a polynomial, because this is x to the minus 1, and remember, negative powers are not allowed for our x. The square root of 2x plus 5 is not a polynomial, because what is inside here? This is square root of 2 times square root of x, which is x to the 1/2 plus 5. We don't allow rational powers, so that's not a polynomial. These are not polynomials. And you might see something more complicated. X squared minus 3x plus 2 over x plus 3. Not a polynomial. It is a rational function, which we'll discuss later, a rational expression. But it's the division of two polynomials, that's true. The top's a legitimate polynomial and so is the bottom. But this expression is not a polynomial. All right. Well, on that note, let's go back to my list, because now that we have polynomials, which are new mathematical objects, we can now do something with them. For example, we can add and subtract them. And this is a very short unit. Watch, there's very little to say. I'll write it out. That'll be the longest thing I do. Adding and subtracting polynomials. This is all there is to it. Just add, or of course subtract, like terms. That's it. That's all you do. And just for the record, let me do one example to show you how this works. And then you'll have a chance to pause and try a lot of this yourself. Here's the example. 3x to the 4th minus 4x cubed plus 6x squared minus 1 in parentheses. And let's subtract from that 2x to the 4th minus 8x squared minus 6x plus 5. What will that be equal to? Well, as I said, all I have to do is combine like terms. So let me walk my way through it systematically. We'll start with the highest power of x I can find and work my way downward. Now I look through here and I see I have 3x to the 4th. Luckily, both of these are written in that higher to lower form. 3x to the 4th and 2x to the 4th. Now there's a minus in front, so it's 3x to the 4th minus 2x to the 4th, so I get just plain x to the 4th. Then let me look for cubes. There's a cube here. There are no cubes down here. So that's the only cube in the problem. Write it down. Minus 4x cubed. Now let's look at squares. 6x squared. In here is minus 8x squared, but there's a minus out front, remember, which goes through the entire parentheses. So minus minus makes this plus 8x squared. That plus the 6 above gives me 14x squared. Moving down to x powers. There's only one of them, it's here. There's none up here. There's only one here. Minus 6x. There's a minus out front, remember, which goes through. So it's plus 6x. Finally, I look at constants, which are the x to the 0 powers. I have a minus 1 above. Here I have a 5 with a minus. So that's minus 5 and minus 1, minus 6. And there I have added these two polynomials. Actually, I've subtracted them, you see. But the addition and subtraction ideas are the same. And now I am finished with adding and subtracting polynomials. So here's what you need to do. You need to practice these polynomial expression operations we've just illustrated. Addition, subtraction, and what polynomials are. Write down a few of them, write down a few of questionable polynomials and see if you can tell the difference. We'll be back in a moment. Now we've looked at polynomials, and then we started performing operations on them with adding and subtracting polynomials. The next two operations, of course, are multiplying polynomials and dividing them. Let's look at multiplying polynomials first. So, multiplying polynomials. Let me first give you a few general remarks, and then I'll do this by example. What is used here, what is at the basis of everything I will be doing, are what are called distributive properties of the real number system, because the variables, of course, are going to represent real numbers. And that just means, for example, if you have 2 times 3 plus 5, that's the same thing as 2 times 3 plus 2 times 5. Because if you do either one of these, this is 8 times 2, that's 16. And what do you have here? 2 times 3 is 6 plus 10. And so those are obviously equal. To bring this 2 across and multiply it times both of those is called the distributive property of the real numbers. The other point I wanted to make here before we get started is it is very important to organize your work. And organizing your work is not to make your instructor happy. It is to make your work easy to read for anyone trying to read it. And remember, you're the first person who's going to be reading it. And you'll be looking back at this work. And you'll be wanting to follow it in case you make errors. So organizing your work is for you and for your thinking. It's not for me. All right. Let's go ahead and look at some examples of multiplying polynomials. And you'll see that there are 2 standard methods of doing this by example. All right. What I want to do, first of all, I'll do a method that I'll just call distributing. Now this is sort of a horizontal method of multiplying. It's a simple idea, and with practice you may prefer this. You may find this to be what you like to do. Let's multiply 2x plus 5 times x cubed minus x plus 2. So I'm taking something simple, a couple of small polynomials, and we're going to multiply them together. Now here's how this distribution works. Whichever one is first, and it probably would pay to put the one with a smaller number of terms first, but it doesn't make any difference. This process works either way. First, take the first term, and now we will multiply it by everything in the other polynomial. Then, having done that, we will take the second term and multiply it by everything in the other polynomial. So if we're systematic, it should not be hard. And then we will add and subtract as we go. So, 2x times x squared, I'll even write that out, 2x times x squared is the first one. Then 2x times a minus x, that'll be minus, or 2x, excuse me, plus 2x times a minus x. Let's leave the minus in there for the moment. 2x times 2, so plus 2x times 2. And now I've finished up with my 2x's. I go back to the 5. Plus 5 times x squared, that's the first term. Plus 5 times minus x, there's the second one. Plus 5 times the 2, like that. Now, of course, if you were doing this on your own, you'd probably collapse some of these operations. 2x times x squared is 2x cubed, and then minus 2x squared for these two multiplied together. Here we have a 4x. Then underneath, I get things that are starting to look like the first line. I get 5x squared. You know what I'm going to do? I'm going to line it up underneath here. Plus 5x squared. This is just for my convenience. There's no not necessary form here. It makes it easier for me. 5 times minus x is minus 5x, and then I have plus 10. Now see, by cleverly rearranging this, I can now just add my like terms easily. See, my like terms are above one another. 5x squared minus 2x squared is 3x squared. 4x minus 5x is minus x, and then plus 10. And lo and behold, I have multiplied these two polynomials together. I've done it by distributing each term over here on the left times each of the ones on the right, and doing it with each term. Now, if you're methodical in your work, this is not very hard to do. But let me show you a little bit more visual way to do this that you might like better. It makes no difference which way you use. I'll write or here so you see that there's no difference. Now this way, I don't know, you want to call it box, you want to call it by a table, whichever way you like. Here's what I'm going to do. I'm going to create a little box, or a table if you like here. And across the top, let me bring back the polynomial I had, the pair of polynomials, 2x plus 5 and x squared minus x plus 2. Across the top, I'll put the second one. Of course, it doesn't matter which one I put there. I'll put x squared, then in the middle I'll put minus x and then 2. Remember, the minus should go with the term. It's not, don't consider it an operation sign, consider it a negation. So it's x squared plus a minus x. Put the minus with here. And then the other polynomial, remember, was 2x plus 5. So I'll put 2x here and 5 here. And then I'll just draw in lines separating all these different terms, like so. Now, I just multiply. This row is 2x times x squared, gives me 2x cubed. 2x times a minus x is minus 2x squared. 2x times 2 is 4x. 5 times x squared is 5x squared. 5 times minus x is minus 5x. 5 times 2 is 10. Let me double these lines here to make that look a little better. Now see, I have all the terms I need. I will add everything that's in here. And notice I can add sort of on a diagonal.